Welcome to The Explainer. We're always told that AI is basically magic, but today we're going to pull back the curtain because underneath all that complex code, AI really just runs on math. And here's the crazy part. It's the kind of math that our own human brains are surprisingly really bad at.
To really get this, we're not going to start with computers or algorithms. Nope, we're going to start with a very human problem, a terrifying medical test result that's going to put your intuition on the spot.
So here's the scenario. Imagine a new test for a serious disease is 99% accurate, and you test positive. Now, what's the probability you actually have the disease? Take a second. If your gut instinct is screaming 99%, you're definitely not alone. But the real answer is shockingly different. And to understand why, we first have to explore a fundamental flaw in how we all think.
See, the problem here isn't really the test. The problem is us. Our brains have these little built-in blind spots when it comes to numbers. So let's follow the clues together and see just how they lead us astray.
Okay, our first clue is all about scale. Simply put, our brains never really evolved to grasp the massive numbers that are all around us in the modern world. And that leads to some huge misunderstandings. This visualizes the problem perfectly. If you have a number line from 0 to 1,000,000, the number 1,000 is barely even off the starting line. Our brains tend to just lump 1,000 and 1,000,000 into the same mental bucket labeled a lot. We don't really feel that one is 1,000 times bigger than the other. And this mental scaling mistake, it pops up everywhere.
A classic example of this is the old story about the chessboard. So the inventor of chess asks for what sounds like a small reward: 1 grain of rice on the first square, 2 on the second, 4 on the third, just doubling it each time. The emperor agrees, thinking it's no big deal. But by the time they get to the last square, he owed 18 quintillion grains of rice, which is more rice than has ever existed.
And this really highlights our core problem. Our brains think in straight lines, but the world often grows exponentially. It's why we consistently underestimate things like how quickly a virus can spread, or the truly mind-boggling size of the data sets that train AI models. Our intuition just breaks.
All right, on to our second clue. This one is about a word we all use every single day without thinking twice: average. It feels so safe, so representative, but it can be a master of disguise.
Imagine a group chat with a dozen normal working people. Their average net worth might be a couple $100,000, a number that seems to represent the group pretty well. But then, Elon Musk joins the chat. Suddenly, the average net worth shoots up into the billions. That number is now completely meaningless. It doesn't represent anyone in the group, not even the billionaire.
And this is a huge problem for AI. A lot of these models are built assuming data fits into a neat, perfect bell curve, where the average is a meaningful center. But the real world, it's messy. It's full of these extreme outliers, the billionaires in the group chat that can pull the entire model completely off course.
Our third and final clue is one of the oldest mental traps in the book. We are pattern-seeking animals. We just love to connect the dots, even when there's no real line between them at all.
The classic example says it all. In the summer, people buy a lot more ice cream. Also in the summer, shark attacks go up. The data shows a perfect correlation, but does one cause the other? Of course not. There's a hidden factor, hot weather, that makes people do both things: swim more and eat more ice cream.
AI is the ultimate correlation machine. It can sift through massive data sets and find tiny patterns we would never, ever see. But it has no real-world understanding. It's got no common sense. So unless it's guided very carefully, it can't tell if a pattern is a real cause or just a random summertime coincidence.
Okay, we've got our clues. Our brains struggle with scale, we get fooled by averages, and we mix up correlation and cause. Now let's bring it all together and go back to that terrifying test result to find the real answer.
So, we know the test gets it right 99% of the time. That also means it gets it wrong 1% of the time. That's the false positive rate. But here's the piece of information our brains just completely ignore, the clue we didn't even know we needed. How common is the disease in the first place? For something like male breast cancer, the prevalence is incredibly low.
And this is where the math becomes incredibly revealing. If you test 1,000,000 men, because the disease is so rare, the odds are that only one man actually has it. He's the true positive. But then you have that 1% error rate. You have to apply that to the 999,999 healthy men, and 1% of almost 1,000,000 is nearly 10,000. 10,000 false alarms. And here is the key takeaway.
A positive result doesn't mean you have a 99% chance of being sick. All it means is that you've been moved from the general population into a much smaller group, the group of people who tested positive. And as we just saw, that group has one sick person alongside 10,000 healthy ones.
So your chance of actually having cancer is 1 divided by about 10,000. That's not 99%. It's about 0.01%. The initial shock completely gives way to the statistical reality. Your intuition was completely, utterly wrong.
So why does all this matter? Well, because this isn't just a math puzzle. This way of thinking is a critical tool for navigating a world that's being shaped more and more by data and algorithms every single day.
Understanding this simple principle, that the starting probability changes everything, it makes us all better thinkers. It forces us to ask the right questions. What's the context here? What was the baseline assumption? Is this AI output truly meaningful, or is it just finding a pattern in a million healthy people?
We are absolutely wired to want certainty. We want to find simple cause and effect stories in a world that is overwhelmingly complex and often pretty random. And, in a way, AI is just a reflection of that desire. It's our tool for imposing logic on chaos, but just like us, it can be completely fooled when that simple logic doesn't match reality.
And this brings us to our final, crucial question. AI isn't magic, it's a probability engine, just like that medical test. So the next time an AI gives you an answer that feels 99% certain, it's worth stopping to ask, what's the hidden context here? Am I the one true positive, or am I one of the 10,000 false ones? It's in that moment of healthy skepticism that true understanding really begins.